Welcome to the Platform Engineering Playbook podcast, where everything you hear is built, reviewed, and improved by AI, by me, and by you, the listener. This show keeps me, and hopefully you, up to speed on the latest in platform engineering, SRE, DevOps, and production engineering. It's a living experiment in how AI can help us track, explain, and discuss the fast-moving world of infrastructure. Every episode is open source. If you've got something to add, correct, or challenge, head to platform-engineering-playbook.com. You'll find all the content and a link to the GitHub repo. Open a pull request, join the conversation, and make the playbook smarter. Let's get into it.
You've built multi-region architecture, Aurora global database, DynamoDB global tables, EKS clusters across regions, transit gateway connecting everything, observability, DNS failover. It works beautifully in staging. Then you get the AWS bill. $15,000 per month becomes $112,000 per month. Your manager asks why multi-region costs 7.5 times more. You explain it's for reliability. They ask if 7.5 times is normal or if you over-engineered. Today you're learning the real cost structure of multi-region and how to optimize without breaking reliability. Not the vendor promises. The actual math with all the hidden multipliers. By the end of this lesson, you'll understand why multi-region costs 7.5 times single region, not the 2 times vendors claim. The 4 categories of costs: compute redundancy, data transfer, replication overhead, and operational complexity. Optimization strategies that cut costs by 40% without sacrificing RTO, reserved capacity versus on-demand trade-offs, and a make-or-break ROI calculation for your specific revenue and risk profile. Let's start with the cost breakdown nobody explains honestly. Vendors say multi-region doubles your costs. 2 regions, 2 times the infrastructure. Sounds logical. Reality, 7.5 times for hot-warm, 10 times for hot-hot. Here's why. Category 1, compute redundancy. You're not just paying for 2 regions, you're paying for capacity to handle full load in the secondary during a failover. Hot-warm means the secondary runs at 20 to 30% capacity idle. You're paying for compute you're not fully using. Example, US East 1 primary needs 10 R6G.4 extra large instances to handle production load. US West 2 secondary needs 3 R6G.4 extra large instances at minimum to maintain a warm state. That's 13 instances total versus 10 for single region. 1.3 times compute cost just from a hot-warm architecture. But it gets worse. During failover, the secondary needs to scale to 10 instances immediately. EKS autoscaling takes 2 to 3 minutes. So you keep the secondary at 50% capacity, 5 instances, not 30%. Now you're paying for 15 instances total, 1.5 times compute cost. Category 2, data transfer. This is where costs explode. Cross-region data transfer costs 2 cents per gigabyte. Aurora replicating 1 terabyte per day equals $20 per day. $600 per month. DynamoDB replicating 500 gigabytes per day, $300 per month. Application logs, shipping to centralized observability, another $200 per month. Total, $1,100 monthly just for data transfer. Single region has 0 cross-region transfer costs. Multi-region adds $1,100 just for moving data between regions. Category 3, replication overhead. Aurora global database costs the same as regular Aurora plus cross-region data transfer. But DynamoDB global tables? You're paying write capacity units for every write in every region, plus replication WCUs. 3 regions means you're paying for writes 3 times, plus replication to 2 other regions. 5 times WCU cost compared to single region. Episode 6 example. 1,000 writes per second, 3 regions. 3,000 WCUs for application, writes plus 2,000 WCUs per region for replication. 9,000 WCUs total versus 1,000 for single region, 9 times cost. Category 4, operational complexity. Multi-region requires more sophisticated monitoring, more complex deployment pipelines, more testing. Engineer time costs too. One senior engineer spending 20% time on multi-region operations equals $30,000 per year in opportunity cost. Add it all up. Single region infrastructure, $15,000 monthly. Multi-region hot-warm, compute 1.5 times, $22,500. Data transfer, plus $1,100. DynamoDB, if applicable, plus $30,000. Operational overhead, plus $2,500, monthly amortized. Total, $66,100 monthly. $66,000 divided by $15,000 equals 4.4 times. And we haven't counted redundant monitoring tools, additional CloudWatch dashboards, X-ray tracing costs, or DR testing. Real multiplier, 7 to 7.5 times. Hot active pushes this to 10 times because both regions run at full capacity all the time. Now, optimization strategies that actually work. Strategy 1. Right-size secondary capacity. Don't run the secondary at 50% if you can scale fast. EKS cluster autoscaler can go from 20 to 80% capacity in 90 seconds. Run secondary at 25%. Cut compute redundancy from 1.5 times to 1.25 times. Save 25% on compute. Strategy 2. Use provisioned capacity for DynamoDB where traffic is predictable. On-demand costs 5 times more than provisioned. For steady workloads, provisioned saves 80%. $63,000 per month on demand becomes $12,000 on provisioned. $51,000 annual savings. Strategy 3. Minimize cross-region data transfer. Keep reads local. Episode 4's service mesh with locality-aware routing keeps 90% of traffic within the region. 10% cross-region for failover only. Cut data transfer costs by 90%. $1,100 becomes $110 monthly. Strategy 4. Selective global tables. Not every DynamoDB table needs multi-region. User sessions, shopping carts. Yes. Static reference data, marketing content. No. Replicate only tables that require active writes. Cut DynamoDB global tables cost by 60%. Strategy 5. Tiered observability. Don't ship all logs cross-region. Keep debug and info logs local, ship only errors and warnings to central aggregation. Cut CloudWatch costs by 70%. $4,000 becomes $1,200 monthly. Strategy 6. Reserved instances and savings plans. Commit to a 1-year or 3-year term for baseline capacity. RDS reserved instances save 40%. EC2 savings plans save 35%. For multi-region architecture you'll run continuously, this is obvious. $12,000 monthly becomes $7,800 with reservations. $4,200 annual savings per instance. Strategy 7. S3, intelligent tiering for logs and backups. Logs older than 30 days move to infrequent access automatically. Saves 50% on storage. $300 monthly becomes $150. Real optimization example. SaaS company, hot warm with Aurora, DynamoDB, EKS. Initial monthly cost, $112,000. After optimization, right-size secondary from 50 to 25% capacity, saved $8,000. Provisioned DynamoDB, saved $40,000. Locality-aware routing cut, data transfer 90%, saved $10,000. Reserved instances for baseline compute, saved $15,000. Selective log shipping, saved $2,800. New monthly cost, $36,200. Savings, 67%. Still multi-region, still 5-minute RTO, but financially sustainable. The ROI calculation you need to run. Multi-region costs more. Is it worth it? It depends on your revenue at risk and outage probability. Calculate revenue per hour. 1 million per year equals 114 per hour. 10 million per year equals 1,140 per hour. 100 million per year equals 11,400 per hour. Calculate outage probability without multi-region. AWS single region SLA is 99.99% annually. That's 52 minutes downtime per year. For most workloads, actual downtime is higher. Call it 4 hours annually from AZ failures, service outages, DDoS attacks. Calculate the cost of those 4 hours. 1 million annual revenue equals $456. Not worth multi-region. 10 million equals $4,500. Still probably not worth it unless downtime has regulatory implications. 100 million equals $45,600. Now we're talking. Multi-region incremental cost. Optimized architecture costs $21,000 extra monthly, $252,000 annually. Payback. You need to prevent 5.5 hours of downtime per year to break even at 100 million revenue. With a typical 4-hour exposure, you're at 72% of break even. But add business impact beyond revenue. Regulatory fines for downtime. Customer churn after outages. Competitive damage. Brand reputation. For many enterprises, these intangibles justify multi-region even when pure revenue math doesn't. Reserved capacity versus on-demand trade-offs. Reserved instances save 40% but lock you in. A 1-year commitment, you're paying whether you use it or not. For baseline capacity you'll run continuously. This is a no-brainer. Primary region compute, primary RDS instances, minimum secondary capacity. Reserve it all. But don't reserve burst capacity. Auto-scaling in the secondary during failover should use on-demand. You're only paying for those instances during actual failover events, maybe 2 hours per year. On-demand costs more per hour, but you use them so rarely it doesn't matter. DynamoDB provisioned versus on-demand. Provisioned requires accurate capacity planning. Get it wrong and you're throttled. On-demand scales automatically, but costs 5 times more. For tables with unpredictable traffic, on-demand is safer. For tables with steady traffic patterns, provisioned saves massive amounts. Analyze your CloudWatch metrics. Make decisions per table. Common cost optimization mistakes. Mistake 1. Over-provisioning the secondary region. Teams run the secondary at 70% capacity, just in case. You're paying for compute you don't need. If your primary fails, you have time to scale the secondary. 5 minutes of reduced capacity during rare failovers is acceptable. Fix. Run secondary at 25 to 30%. Scale on demand. Mistake 2. Replicating everything. Teams enable global tables on every DynamoDB table. Ship all logs cross-region. Replicate all S3 buckets. Most of this data doesn't need multi-region. Fix. Be selective. Only replicate what's critical for RTO, RPO. Mistake 3. No cost monitoring. Teams build multi-region, don't track costs per region or per service. The AWS build doubles or triples, and they're surprised. Fix. Tag all resources with region and service name. Use Cost Explorer to break down spending. Set up billing alerts. Mistake 4. Ignoring FinOps culture. Engineers don't think about costs, they just provision. No accountability for spend. Fix. Make cost a quality metric. Review multi-region costs monthly. Set targets. Incentivize optimization. Before we wrap up, pause and answer these questions. Question 1. Why does hot-warm cost 7.5 times single region instead of 2 times? Question 2. Your application generates 10 million per year revenue. Multi-region adds 20,000 per month cost. Is it worth it? Question 3. Should you use reserved instances for primary compute and secondary burst capacity? Take a moment. Answers. Question 1. 4 cost categories. Compute redundancy, 1.3 to 1.5 times from running secondary capacity. Data transfer, 1,100 plus monthly for cross-region replication. Replication overhead, DynamoDB global tables costs 5 to 9 times WCUs. Operational complexity, 2,500 plus monthly. Total multiplier, 7 to 7.5 times. Question 2. Probably not from pure revenue math. 10 million equals 1,140 per hour. 4 hours downtime per year without multi-region equals 4,500 cost. Multi-region adds 240,000 annually. You'd need to prevent 210 hours of downtime to break even. Unrealistic. Unless you have regulatory requirements, customer retention issues, or brand damage concerns that justify it. Question 3. Yes for primary, no for secondary burst. Primary compute runs continuously. Reserve it and save 40%. Secondary burst capacity only runs during rare failover events. On-demand is more expensive per hour, but you use it so rarely that total cost is lower than reserving capacity. You don't use 99.9% of the time. Let's recap what we covered. First, multi-region costs 7.5 times single region for hot-warm, not 2 times. Compute redundancy, cross-region data transfer, replication overhead, and operational complexity all contribute. Second, optimization strategies cut costs 40 to 60% without sacrificing reliability. Right-size secondary capacity, use provisioned DynamoDB, minimize data transfer with locality-aware routing, selective replication, and reserved instances for baseline. Third, the ROI calculation requires revenue per hour, outage probability, and business impact beyond revenue. For most workloads under 10 million annual revenue, multi-region math doesn't work. Above 100 million, it usually does. Fourth, reserved capacity for baseline, on-demand for burst. Don't over-reserve capacity you won't use. Analyze actual usage patterns and reserve accordingly. Fifth, FinOps culture matters. Track costs per region and service, set targets, review monthly, and make engineers accountable for spend. Remember Episode 1's CCC triangle? Cost, complexity, capability. Multi-region maximizes capability at the expense of cost and complexity. Today you learned how to optimize that trade-off, reducing cost from 7.5 times to 4 times while maintaining the same capability. We'll revisit cost optimization in Episode 12 during disaster recovery planning. You'll calculate the actual cost of a DR test, how to minimize it, and how to justify multi-region spend to finance when they question the bill. Next time, data consistency models, the CAP theorem in production. Episodes 3 and 6 taught you about Aurora and DynamoDB replication, but we glossed over consistency. Strong consistency, eventual consistency, read after write consistency. What do these actually mean in multi-region? You'll learn the CAP theorem, why you can't have consistency, availability, and partition tolerance simultaneously. How Aurora chooses CP and DynamoDB chooses AP. Consistency models. Strong, eventual, causal, read your writes. Real examples of consistency bugs that caused data corruption. And how to design applications for eventual consistency without losing user trust. Because multi-region forces you to choose. Perfect consistency across regions or high availability. You can't have both. Let's make sure you choose correctly for your use case. See you in Episode 10.
That's it for this episode of the Platform Engineering Playbook podcast. Every topic, transcript, and summary you just heard lives out in the open at platform-engineering-playbook.com, where anyone can suggest updates or add insights through GitHub. If you've got thoughts, fixes, or new ideas, open a PR. And if you enjoyed the episode, rate us on your favorite podcast platform. We're always shooting for 5 stars. While you're there, give the project a star on GitHub. It helps others find and contribute to the Platform Engineering Playbook. This podcast is generated by AI, reviewed by AI, me and you, a community of engineers keeping our craft sharp. Thanks for listening, and see you next time inside the Platform Engineering Playbook.